And there we are with live. So welcome back. We're continuing here the whole process towards building the prioritization for some amphibians in Mexico. Last time we talked all about the whole projections. We show how we did the projections, and we kind of view or review the values, and we constructed the files that we will be using for the following software that is called Zonation, which is the one where we are going to do the prioritization, the geospatial prioritization. So now what I'm going to go through very quickly, it's going to be a short video hopefully, it's just a couple of post processes that we need to do. One, to compare the maps from the species, because it's important just to take a look at the maps themselves and to see where they are located. I think we can take a look a little bit, because there will be some observations that could be interesting, right? And also we need to get some things ready in order for Zonation to be able to use those maps. So the first part here, if you go to our trusty R Studio, because I'm a basic person, this is basically where we left off. Yeah, building the ASCII files, which are the maps. Fine. Now, when we build the ASCII files, the scores that we will have, they will all be different. So we need to have them standardized in order to be comparable, right? In order to be usable even. And so this is basically what I did over here in a very quick code. I'm not going to run them because I already have the products. So what we have here is just okay. So the idea is to bring the object. Yeah. So we bring the object, we read it in raster, and then we acquire the values. So coming from a map, which is the whole picture, right? What I want to have is just one string of values. Once I have the string of values, I need to know which is the maximum value within that specific map. Once we have that, we can start dividing among the other maps. So that's going to give us the proportion. We arrange those values, and we finally write them back in a map. So that was done for current. Remember that, because I'm still using the old map, because this is just for you to see this information can be updated. So current time was 2010, which I still use. The environmental information available is 2010. I'm not sure. There should be an update. For the past, we have 1979. And for future is 2030, right? Also, this is based on the RCP, which was an environmental model assuming the worst case scenario, where you have no policies implemented to reduce all the emissions and all that kind of stuff for climate change. So basically what's going on right now. I mean, we do have policies, but nobody is doing anything in order to slow down the whole emission thing. So I run that for all of them, and this is how it actually looks. I already have them ready. So what I want you to see, yeah. So the first one, let me put some. So this first one that I have here, let's use, I don't know, blue, yes, yeah. So this is the original one. So you can see that I have a minimum of 101 and a maximum of 198, okay? Our standardization, as you see in the other three cases, this is the future one. Every time that we see F85 means that this is the future scenario. So as you can see in the other cases, we have in the standardization 0 to 1. Well, a little bit less than 0. Let me change the colors from the other ones and then we can take a look at them. Let's just take a quick look into our products here. I'm going to turn off this guy. Yeah, I have them here, not georeference. I have them already georeference here, but I don't know if I want to get into it right now. But anyway, I just want to visually see the thing. But for the past conditions, this is how it looks. The brighter, the highest. So we have a predominancy. You know what's going to help? What's going to help? Let me see. Okay, pause. I need to pause. I'll be back. Okay. So after that, quick pause. Nobody noticed. Everything's in order. So I have the information over here already georeferenced. So it should help with visualization, right? So I wanted to see the one from the past first. Yeah. So I have the highest values up here in the north. Almost nothing. Yeah. Taking consideration that for the environmental data for past, I think I really don't know the quality of the records. Here we need to understand that when we do this kind of work, we are at the mercy of quality in one hand, right? Like, do we have enough stations, meteorological stations? Are they the information captured there? Is it reliable or not? So when I'm looking here on a map that is supposed to have 1978 information, 79. We need to take that in consideration. We don't know the quality, but we need to trust what we have here. Right? And that also goes even to the current information, right? We always have human errors, right? So I'm already going to see a very big shift. Here, for example, yeah, this is exactly what I was about to bring up. Can I use it better? Let me invert it. Okay, so the highest values that I have here, close to Mexico City, I am pretty sure that we have. This is why we need to, first, I mean, I'm not familiar with the whole topography and vegetation of the area, but as you can see, it's covering a hilly place, but it's not very hilly. I think they are actually for real mountains. So can you see that? Boom. And actually, I do know this area. This is a volcano that is not active, a very famous one. And you can see how it actually is just the highest values are surrounding that area. You see the ring. So this is kind of interesting. Let me turn on once again the one from past. So for past conditions, we have a very different scenario. Yeah, this looks flat. So just to repeat myself, all the information that we see represented here is environmental information. Yeah, it's only based on environmental information, which is really interesting to see outside of climatic and environmental information that I have very two places topographically different. Yeah. And how does the future thing looks like? This is another thing that is also extremely weird. So we still we need to be very careful what could be the interpretation of that. Because all the areas that are supposed to have the climatic suitability are cities. This is super strange, but it's something that we need to take in consideration when we're going to discuss and analyze this kind of data. One of the reasons why we might have this kind of bias, I cannot call it necessarily a mistake, but bias, is the information that we get from the species, the occurrences, the points, the locations of the species, that are collected by humans, and humans can only go as far as they are able to. And a lot of the records sometimes can even be from scientific collections which are located in cities. I don't think that's what's going on over here for the future, but yeah, it's quite interesting. I might ask some of my ex-peers. But anyway, so I wanted to cover what I wanted to cover. We'll continue with zonation and how to set up, how to bring the maps, and yeah, all that jazz. And hopefully in less than 3 videos we can have the final results. So until the next one, be good, bye-bye.